These are the current shoes we're making. They consist of about 50 different parts.
Many of the features in sports shoes today are the direct result of his research. Waki believes to understand the design of a running shoe, you first have to understand the way you run, and every single step has 5 distinct phases. A special pad on the insole of a sports shoe shows the pressure at different stages. By measuring the changes in pressure, Waki attempts to deduce how to get the best performance out of a running foot. It's called motion guidance.
Motion guidance line is very important for designing the running shoes. Based on this line's position and the direction, we designed the reinforcement direction and groove direction, increasing the gripping property.
Studying how the foot works is vital for developing sports shoe designs. Yet the mass production of those designs takes place not in Kobe, but hundreds of kilometers away. It's midday in the Chinese city of Dongguan, and the shifts are changing for the 5,000 workers at the Yueyan factory. The making of a running shoe is split into 3 sections: the rubber sole, the midsole, and the shoe's fabric upper. The perfect sole starts with rubber. The amazing thing about rubber is how versatile it is. One block can be turned into 1 million products. What's important on the sole of the sports shoe is grip, and getting the right gripping property is like cooking. These guys are, in effect, rubber chefs. Welcome to the ingredients cupboard. In this lab are different chemical compounds, each carefully weighed and added to the rubber. These give it its different qualities. Everything is thrown into a mixing machine, where it's cooked and kneaded like dough. Giant rolling pins flatten out the rubber dough before it's stretched into long, thin sections. This gunge must now be turned into a running shoe. The rubber is placed carefully into metal molds, like sandwich toasters, and pushed into ovens to melt them into shape. It's hot work. Each section of rubber is built up through a series of molds to make a finished composite sole. Finally, the rubber sole emerges with all its various textures and patterns. It might seem like a work of high fashion, but there's real science in this sole. Back in the research lab in Kobe, today Waki's looking at heels. The heel takes the most impact when running. It's the foot's natural shock absorber. That's why there's so much skin and tissue there. But with 4 times the body weight of the runner pounding on the heel, that's a lot of potential damage. So what is Waki's solution?
We inserted this intricately designed gel at this position and at this position. These gels absorb high ground reaction force in running.
The gel is so good at absorbing and dispersing energy from impact, they proudly said it could even prevent an egg breaking from 6 meters. So we put them to the test.
きます。
The special gel disperses the energy of the impact outwards rather than straight down, spreading the force, not compacting it.
OK, it's not broken.
And just to prove it's not broken, back in China, on the assembly line, this gel is glued in between two parts of the midsole. The completed midsole has all the gels, cushioning and support elements. It just needs the finishing touch, the molded rubber sole. All that's left is for the midsole to be checked and cleaned. Now the underside of the running shoe is complete. Back in Japan, Waki is looking at the way the foot moves and how that affects the upper section of the running shoe. As it lifts off the ground, the foot is at its most deformed. All the straining is on the joints around the toes. This uneven strain distribution causes the running shoe to scrunch up behind the toes.
Yes.
What Waki has done is apply a stretchable fabric in between.
We inserted new stretching materials on here. We called it biomorphic fitting systems. These stretching materials interrupted the strain continuity from here to here. Okay.
Waki's designs all need to function in extreme conditions. This special climate-controlled chamber generates temperatures ranging from 60 degrees to minus 15 degrees centigrade. Right now, it's minus 15. This guy's running in the Arctic. The climate chamber also monitors another factor when running: sweat. There are 250,000 sweat glands in the feet, more than any other part of the body. They excrete up to half a pint of moisture a day. The foot needs to breathe. The solution is multi-layered gas-permeable fabric. The fabrics are concentrated on the top section of the shoe called the upper, which is the final part of the running shoe's manufacture. Layering fabrics is part of the secret of breathability. The uppers are wrapped around thousands of plastic feet, called lasts. An insole is hammered onto the bottom. Each batch of lasts is for a particular shoe size. One of these has your number on it.
It's not easy to make a shoe. By the time it's finished, it has gone through 300 pairs of hands.
The shoe is cooked over a grill and clamped around the last. The heat softens the rubber, which is then squeezed into a finished shape. Now, it may look like a running shoe, but no one's going running just yet, not without a sole. Two conveyors bring the sole and the upper part to be glued together. Finally, the laces are tied, the running shoes are cleaned and boxed, ready to be sent around the world to where size 10 feet need them. The appetite for running shoes is voracious. US sales alone exceed $14 billion. In China, 300 pairs of hands have put together 50 separate parts to produce a marvel of engineering. Back in Japan, planning the next running shoe has already begun. Five ordinary objects, 5 extraordinary stories. Coming up, they're bigger than a city block, monstrous creations of iron and steel, yet they build them just like Lego. The secrets behind ship construction, next, on How Do They Do It? % of world trade is moved by ship. As demand for products increases, ships need to be bigger and stronger to accommodate the growing volumes of cargo. In Korea, they've taken shipbuilding into the 21st century. So when it comes to putting together a modern-day super cargo ship, how do they do it?